Okay, 17. So again, think to yourself, we just made that little flow chart, and is there a GCF here? The answer would be no. And how many terms is this? Is it 2 terms or 3 terms? And hopefully you said 2 terms. So this is either a dots or a sots. So a dots means difference of 2 squares, and sots means sum of 2 squares. So this would be a sots. So this would be a sots I. We just put an I there because what's happening is you're forgetting the I. So think sots I, and that will if I could talk, that would be great. Hopefully help you with remembering, don't forget that I, because that's I is what changes that to a positive instead of it being a difference. So then we think, okay, what's the square root of 4x squared? And hopefully you would say 2x. And the square root of 81 would be 9. Remember, sots I, so don't forget your i's, and one's got to be positive, one's got to be negative. So now you set each one of these equal to 0. So you subtract over your 9i, and you get 2x is equal to 9i, and then divide by 2, because we want to get x by itself. Okay, same thing on the other side, except we're going to add over 9i and divide by 2. So then our answer is x equals, and you can either write it negative 9 halves I, or you can say plus or minus 9 halves I and write it as 2. Okay, 18. So on this one, we don't have a GCF. It's 3 terms. A is equal to 1, so we factor. So factors of 24 that are going to add to give you negative 11x. Well, to do that, they have to be same signs, and they're both going to be negative. So factors of 24 that are going to add to give you 11 will be a negative 8, and a negative 3 will give you a negative 11. So set those equal to 0. So x will equal 8. X will equal 3. So x equals 3, 8. Let's try my brackets a little better here. Okay, here's 19. So 19, is there a GCF? No. Is there 2 terms or 3 terms? It's 3 terms. And is A equal to 1? No, it's equal to it's equal to a 3. So when it's not equal to 1, we do slide and divide. Or you could do grouping. So our method of slide and divide, we multiply that 3, we slide it over to that negative 1. So we get x squared plus 2x. And so 3 times negative 1 is going to be a negative 3 is equal to 0. And so now we're back to where a is equal to 1. So at this point, we can just factor like we normally do. So remember, this is a negative, so we've got to think they're going to subtract. So what are factors of 3 that are going to subtract to give us 2? Because they're going to be different signs. So hopefully you'll say 3 and 1. And so the 3 must be the positive because it takes that sign. And positive 3 minus 1 will give us a positive 2. If we had switched the signs, a negative 3 plus 1 would not have given us a positive 2. It would have given us a negative 2. Now, the biggest mistake kids will make is they'll stop right here, and then they'll set them equal to 0. But the other part of this is the divide part. So you can't forget to divide. So we have to divide out our A. Well, to divide out our A, you would divide each of these by 3. So then you get x plus, well, 3 divided by 3 is 1. And then we can't really simplify this one. So at this point, we can leave that alone and then set each one of these equal to 0. So subtract a 1 over, you get a negative 1. Add a 1/3 over, you get a positive 1/3. So our answer is x equals a negative 1, comma, a 1/3. Well, 20 ended up being the same thing as 18, so let's not worry about doing that. I could add another one if we wanted to, but we want, the only other thing that maybe we would want to do is another slide and divide. But if I have time, I might add that, but let's keep going for now. Okay, so now we're going to solve for taking the square root. So on this one, this should not have the x right there. So go ahead and get rid of that x. There should be no x there. Or we can't do the taking the square roots on this one. So what we can do here is we can subtract over. Remember, we need to isolate that x squared for square root. So let's subtract over that 48, and then let's divide by 4. So we get x squared is equal to a negative 12. Well, now we can take the square root of both sides, because that will cancel out that x squared. So you get x is equal to, well, remember when we're taking the, sorry, that thing's still on. When we're taking the square root of both sides, we get plus or minus the square root of negative 12. Well, now we've got to simplify this. So if we simplify this, we get a square root of negative 1 and the square root of 12. Square root of negative 1 is I, and then let's break down with perfect squares. So there's a 4 in there, because 4 times 3 is going to give us 12. So you get square root of 4 times square root of 3 will give us square root of 12. But the square root of 4 is 2. We can't break down 3 anymore. So then our answer over here is x equals plus or minus 2I root 3. We can write that over here. And then we're done. Okay, but what about this one? Well, it's already where we've isolated the x. So what we can do is take the square root of 196. So we get x is equal to plus or minus the square root of 196. And if you break this up, you'd get square root of 14 times square root of 14. Well, that's a pair. And this is actually a perfect square. So square root of 196 is 14. So you get x is equal to plus or minus 14. Okay, 23. So we've got to isolate the binomial squared. So divide by 3 to both sides. So we get x plus 2 squared is equal to 16. Now we can take the square root of both sides. And that 2 and that square root end up canceling each other out. So we get x plus 2 is equal to plus or minus square root of 16. Well, what's the square root of 16? Hopefully everybody will tell me 4. So, but the thing is that 2 is in the way of x being isolated. So if we subtract over the 2, we get x is equal to negative 2 plus or minus 4. But the thing is we're not done, because we need to split that out. We get two answers. We get a negative 2 plus 4, and we get a negative 2 minus 4. So negative 2 plus 4 gives us a 2, and a negative 2 minus 4 gives us a negative 6. So our answer is negative 6, comma 2. Okay, last one in square roots. Same thing here. We've got to divide by 4. Got to isolate that first. So we get x plus 2 squared is equal to a negative 4. So then we've got to take the square root of both sides. So we get x plus 2 is equal to plus or minus, and then if we break this down, we get a square root of negative 1 times the square root of 4, and that gives us I, and square root of 4 is 2. So we get 2I. Then if we subtract the 2 over to both sides, we get x is equal to negative 2 plus or minus 2I. Okay, so what if that wasn't a perfect square? So let's just kind of go off for just a second. So what if, let's say we had a negative 7. So if we did this and we took the square root here, square root both sides, so I'm just making up a problem, we would get x plus 2 is equal to plus or minus negative square root of 7, which would be I square root 7. So how would we work this out? Well, we would subtract 2 over to both sides, and you would get x is equal to negative 2 plus or minus I root 7. And then that would be your answer. We couldn't do anything more because we can't add a real number to an imaginary number. So then we would be done. Okay, at this point, I'm going to stop for a second. I'll do another video with the quadratic formula and then writing the roots when I get a chance.